Hi students, let's understand about the Rankine cycle which is used in steam power plants. Rankine cycle consists of four important devices. The first device is boiler, second device is steam turbine, third device is condenser, and fourth device is pump. And all these four devices are connected through pipes. And water is the working fluid which keeps on circulating in this cycle. Now, in addition to boiler, we have a furnace. The function of furnace, we all know, it fires the fuel by consuming air and releases the heat energy. Now, let us discuss about working of this cycle. Water at state 4 in the beginning in the liquid form enters the boiler. That water boils inside the boiler by absorbing Q1 amount of heat energy and gets evaporated, gets converted into vapor and comes out as a steam. This steam may be superheated or saturated or in wet condition. 99% we send superheated steam only inside the steam turbine. The steam from the boiler comes out at state 1. Now with enthalpy H1, the steam turbine absorbs enthalpy from the steam and changes its enthalpy to H2. That is, the state of the steam changes from state 1 to state 2. And the state of the steam coming out of the steam turbine is it's a mixture of saturated vapor plus few droplets of liquefied steam. That is, it's a wet steam comes out with high dryness fraction, that is x equal to 0.9 onwards. Then the wet steam coming out of the steam turbine, it enters the next device called as condenser. So inside the condenser we have a bunch of tubes. So inside the tubes we are sending cold water inside the cold water, and that water absorbs heat energy from the surrounding steam present inside the condenser, becomes hot water. This hot water is sprayed in a device called as cooling tower. So the hot water is sprayed from the top. While it is falling down, it gives away its heat energy to the air present in this cooling tower, and water gets cooled. Then the cold water is again pumped back with the help of a pump into the condenser. Then the steam after ejecting heat energy, to the bunch of tubes gets condensed. That is, it changes its phase from vapor, that is wet steam, to the saturated liquid condition. Then the saturated liquid form of water or condensate at state 3 will enter the next device called as pump. Okay, so this pumps the liquid condensate at state 4 into the boiler. Thus the Rankine cycle is completed. Now let us discuss about the analogy of energy transfers in all these four devices. So the first device, let me consider this as a steam turbine. For this steam turbine, if I apply steady flow energy equation, so this is the steady flow energy equation, H1 minus H2 plus V1 square minus V2 square divided by 2 plus Z1 minus Z2. So if I calculate the change in velocities V1 and V2 across the steam turbine, that value is negligible. I can consider it as a 0. And again Z1 altitude, Z2 altitude, the change in them is also negligible. I can consider that also as 0. So these two terms gets cancelled. The remaining term is H1 minus H2, that is inlet enthalpy minus exit enthalpy across the turbine. So this change gets converted into turbine work. Then the steam at H2 enthalpy, that is in the phase of liquid plus vapor, that is wet steam, enters the condenser, but it is in vapor phase, so hence I can write it as enthalpy as H2. So it comes out as liquid. So since it is a saturated liquid condition, the enthalpy at state 3 we can write it as HF3. Therefore the higher enthalpy H2 minus the lower enthalpy HF3, H2 minus HF3 is nothing but the heat rejected by the steam in the condenser. This equation is obtained by applying steady state, steady energy, steady flow, steady energy equation, SFW equation like this. So then again, the saturated liquid condensate with enthalpy HF3 enters the pump. Here we are adding power or energy, mechanical energy to the condensate with the help of pump. So because of that there is a rise in enthalpy. The final enthalpy is HF4 because it is still in liquid condition. So this higher enthalpy HF4 minus lower enthalpy HF3, the difference of both is nothing but the pump work supplied to the pump. Pump work is supplied as a part of turbine work generated in the Rankine cycle. So this is the WP, that is HF4 minus HF3 supplied to the pump. Now the water again at state 4 enters the boiler. If you apply SFW, steady state steady flow energy equation, to the boiler, then again you will get the quantity of heat supplied to the water inside the boiler. So that is higher enthalpy is H1 and inlet enthalpy is HF4. H1 minus HF4 is the quantity of heat energy supplied to the water inside the boiler. So this is steady flow energy equation. Now let us come to understand the processes inside the Rankine cycle. Now the process 1 to 2, here the steam undergoes isentropic expansion. Hence the process name can be written as process 1 to 2 here. Isentropic expansion in turbine. This is the process 1 to 2. Means entropy remains constant during this. Then again process 2 to 3, what is happening? Phenomena is condensation. So vapor is getting converted into liquid. So there is a phase change. So condensation is happening and at constant pressure. Pressure is remaining constant. So process 2 to 3, what we can write? We write it as constant pressure heat rejection in condenser. Constant pressure heat rejection in condenser. So then again coming to next process, that is 3 to 4 process. What phenomenon is happening? Pumping is happening. Okay. So 3 to 4, so we write it as isentropic compression in a pump. Isentropic. So it is an isentropic process. Entropy remains constant. Okay. We call it as a compression. Since we pressurize the water against the boiler pressure, so we call it as a compression. Isentropic compression in a pump. Then 4 to 1, what we are doing? We are adding heat energy to the water. So that is constant pressure heat addition process in the boiler. So that is 4 to 1 is constant pressure heat addition in the boiler. This is the process. So these are the process names in the Rankine cycle. So after this, let us discuss about PV diagram and TS diagram. So let us represent all these processes on a PV diagram. Let us discuss about PV diagram. So as you know in our previous video, this is saturated liquid line and this is saturated vapor line. Okay, so this is saturated vapor line. This is saturated liquid line. So wherever both meets, it is critical point, and this complete cone is called as vapor dome. So as you know, the liquid is here, liquid region, this is liquid plus vapor region, this is superheated vapor region, this is. So if you represent this process on the vapor dome, as we have discussed in schematic diagram itself, the steam may be superheated condition, or it is saturated condition, or it is wet steam at the inlet of the turbine. So if it is superheated, so I am marking it as state point 1 double dash. So it enters the steam turbine, undergoes expansion inside the steam turbine, and it becomes wet and comes out at state 2 double dash. So then 2 to 3 it undergoes constant pressure heat rejection, that is condensation process. So then 3 to 4 it is compression process, that is pumping process. So 4 to 1 double dash it is again boiler process. So this is the cycle for superheated steam at the boiler outlet. If steam is saturated steam coming out of the boiler at state 1, so it expands to state 2 here. So that is it, wet steam comes out as a wet steam at state 2, and cycle repeats. If it is wet steam at the boiler inlet, so steam enters at 1 dash and comes out at 2 dash, and cycle repeats. So this is PV diagram for this Rankine cycle. Coming to TS diagram, temperature entropy diagram. Temperature entropy diagram. Here again we have vapor dome. This is saturated liquid line, and this is saturated vapor line. Okay, so here it is liquid region, here it is liquid region, here liquid plus vapor region. So here we have superheated vapor region it is. Okay, so important diagram is TS diagram. So all students need to better understand this TS diagram, which will be helpful for solving the problems. So let us begin with the process 1 to 2. So as we have discussed in the schematic diagram, the steam may be superheated or saturated or wet steam. So it may have any condition at the boiler outlet or turbine inlet. State 1, let us mark it on the TS diagram on the vapor dome. So now let us assume that the steam is superheated condition. So 1 double dash has to be marked in superheated vapor region, 1 double dash. This steam enters the steam turbine, undergoes isentropic expansion. Isentropic expansion, that is entropy remains constant here, undergoes isentropic expansion, but its phase changes in the steam turbine. So that is 1 double dash is superheated state point, and 2 double dash. So if it is becoming wet steam at the turbine outlet, so I am marking 2 double dash in the wet region. If it comes out as a saturated steam, we have to mark it on a saturated vapor line. Saturated vapor line. Now it has come out as a wet steam. So then 2 double dash to 3. 2 double dash to 3 is constant temperature heat rejection. Constant temperature, that is condensation is a phase change process, always takes place at constant temperature. This is constant temperature line, 2 double dash to 3. Then 3 to 4 is isentropic compression inside the pump. So because of pumping action, there is a rise in temperature of the water, but it's an isentropic process. S equal to C. 3 to 4 is a pumping process. So 4 to 1 again, since it is in liquid region, so we start adding heat energy. So its temperature of the water rises till saturation temperature, till T saturation. It increases till T saturation, saturation temperature of the water, that is 100 degrees Celsius at 1 atmosphere. So then it is still in liquid condition, because this is saturated liquid line. This is saturated liquid line. It is in liquid phase. So now vaporization starts at constant temperature only, at 100 degrees Celsius only, till all water gets vaporized inside the boiler. So this is at saturation temperature only. So here liquid plus vapor changing, dryness, friction and all we need to consider in this wet region. So at this point all the water present in the boiler has reached saturated vapor condition. Now further addition of heat inside the boiler, it increases the temperature of the steam. That is, this is what temperature? This is T superheated temperature, means superheat temperature of the water. This T superheat minus T sat is called as degree of superheat. Okay, so then again it is heated till superheat temperature. So then again it undergoes expansion. Thus cycle is marked for superheated steam. Now let us take the same TS diagram when the condition of the steam at the turbine inlet or boiler outlet is saturated. When steam is saturated steam, the saturated steam condition is always marked on the saturated vapor line. So this is state 1 at the inlet of the turbine. So the steam enters as a saturated vapor. So then undergoes expansion. At the turbine outlet it must be wet. So then comes out at state 2 with wet steam. Then 2 to 3 condensation, it undergoes condensation. 3 to 4 pumping. So 4 to 1 again heat addition. So this is increase of temperature in the liquid region till saturation temperature. This is vaporization process. Then saturated vapor is produced. So then one more option is third one, that is here the steam at the turbine inlet, if it is in wet condition. So the inlet boiler turbine inlet is boiler outlet or turbine inlet is 1 So 1 must be marked in wet region only. So that is liquid plus vapor region is called as wet region. So 1 I am marking it in wet region. So 1 to 2 So turbine outlet will also come it as a wet steam only. So 2 we are marking here. 2 to 3 it will undergo condensation. 3 to 4 pumping process. So 4 to till saturation temperature, increase in the temperature, but it is saturated liquid only. From here vaporization happens till 1 So 1 2 3. So this is the TS diagram. This is all about the TS diagram. Remember that this is saturation temperature, here it is superheat temperature. Now let us understand about the enthalpy entropy diagram. Enthalpy entropy diagram. This is enthalpy, this is entropy. So here also we have vapor dome. So here completely liquid region, here wet region, liquid plus vapor region. So here we have outside this superheated vapor region. It is superheated vapor region. So here we mark the condenser pressure. So condensation process always happens at constant pressure inside the condenser, as we have seen here. So condenser pressure line, we have condenser pressure line, constant pressure line, and one more is boiler pressure line. So inside the boiler, so there are two pressures which works in this cycle. So one is condenser pressure and another one is boiler pressure. Boiler pressure is also constant, so we draw this line. So now let us begin the cycle from the state 1. As you know, the steam at the turbine inlet may be superheated. So 1 superheated region we have marked. It may be saturated steam. So point 1 is marked on saturated vapor line. Then again point 1 is marked in wet region. So 1 to 2 this is the cycle. Okay, so 1 to 2 this is the cycle, 1 to 2 is the cycle. So three possibilities at the turbine inlet. So based upon that we have marked the processes. So hope all of you have understood this explanation. For any doubts, please feel to contact. Thank you.